Hi guys. Today we get to talk about the digestive system, which might be one of the coolest systems on the planet because it allows you to drop a giant doo-doo on the beach if you are a Y chromosome and are so inclined. Digestive system, in addition to the phenomenal ability to drop a giant doo-doo on the beach, the digestive system is tightly linked to all metabolic processes. Metabolism is essentially the sum of all chemical reactions that happen in your body. So let's take a second to compare digestive processes with metabolic processes. And then we're going to look at some of the inputs to the digestive system and perhaps conclude whether or not we think this young laddie could actually drop that size of a doo-doo on the beach if he so wanted to. Would he want to? I do not know the answer to this question. But it does not matter because we need to know, what is this digestive system? In fact, what is digestion when compared to metabolism? They're not the same thing, and often they're kind of referred to in similar contexts. Digestion, the digestive system is responsible for breaking down food, break it down, break it down, break it down, break it down, and absorbing it into the blood. You remember that the digestive system is nothing more than a tube inside your body. So the lumen of the digestive system is actually outside your body, because remember, there it is, outside my body. And that tube goes all the way through my body and then comes out the other end and is like in the middle of my body, but it isn't actually in me. It isn't actually inside, because inside is like the blood and all my cells and my interstitial fluid, and this stuff is not that. So the other task, I mean, if you have food in the lumen of your digestive system, well, you're somehow going to have to absorb that into the blood, and that's ultimately the value of the digestive system. Breaking it down, you know, here comes your ice cream cone. If you don't break down your ice cream cone into smaller pieces, it's going to be too big to absorb into the bloodstream. Now, another interesting thing that happens, this is more of like a mechanism, a tool to help you do all of this. We have a great deal of secretion going on in the digestive system. And in fact, I've got a slide in just a second where I'm going to show you how much secretion is happening. Now, secretion is putting stuff from the blood or from the cells or from the glands surrounding the digestive system into the lumen. Why would we be secreting stuff into the lumen? Dude, the secretions help you break it down, break it down, break it down, break it down. And once you break it down, that's where metabolism comes in, breaking down your pieces so that you can put them into your bloodstream. Here are my little nutrient pieces. Thank you very much. What are we going to do with those nutrient pieces? Well, in this lecture, we're actually going to look at glucose and what we do with glucose, how we get glucose into our cells so that our cells can use it to go through cellular respiration and make energy. And hopefully at this point in the semester, you're like, dude, energy is kind of important. We can buy that we would have an entire system dedicated to getting stuff in so that we can make energy. Cellular respiration is an example of a metabolic process, a series of chemical reactions that enable your body to function. Cellular respiration is a metabolic process that breaks down substances, complex molecules, and it actually gets energy out. It's an example of catabolism. Catabolism. Catabolic reactions break things down into smaller pieces. Building muscle. This is another example of a metabolic process. You're increasing your muscle mass, you're putting together more myofibrils, you're increasing the diameter of your myofibers. That is an example of an anabolic chemical reaction, or anabolism. Anabolism. And anabolic processes build things out of building blocks. So these little molecules that you just absorbed, these are your building blocks. You're either going to use those building blocks to create energy through catabolic pathways, or you're going to use those building blocks to make more stuff through anabolic pathways. Ultimately, I mean, you're a walking metabolic sum of chemical reactions. Like, that's what's going on in you. Digestion, the digestive system, fuels your resource needs so that you can carry out all your metabolic processes. We're going to look, first of all, at digestion, and then we're going to look at specific mechanisms by which molecules are absorbed into the bloodstream. And then we're going to look at glucose homeostasis and how we maintain proper glucose concentrations in the blood. Before we do that, I have to blow your mind, because, you know, it's just not a good lecture unless your mind is blown. Now take a look at this. First of all, here's just a rough diagram of the anatomy of the digestive system. And what I want you to notice here is that, you know, your digestive system is pretty amazing. You, on average, I don't know how they figured out this number, but we'll just go with it. You ingest 2 liters of fluids and food in a day. Whatever, give or take, however, whatever. If you ingest 2 liters of food and fluid in a day, I want you to look at these numbers and think about this. You actually secrete wholly 7 liters of stuff into your digestive system in a day. That's crazy talk. 1.5 liters, that's almost a 2-liter soda pop bottle of spit from your salivary glands gets secreted into the lumen of your digestive tube every day. That means if you didn't like keep this spit in your mouth, you just like every time more spit came in, you just spit it into a 2-liter pop bottle, you'd almost fill the thing with the saliva that you produced in one 24-hour period. That blows my mind right there. I love having my mind blown. Your gallbladder makes half a liter of bile and secretes that into your mix. Now, we're going to look at bile and why we're grateful that our gallbladder does this for us and why we shouldn't eat a 5-pound tub of butter. Yes, not a wise thing to do. Your stomach is producing 2 liters. There's another pop bottle of gastric juices, digestive enzymes, acids, mush, gush, mucus. Awesome. 2 liters of this stuff. Then go to our pancreas. Just your little friendly pancreas is doing another 1.5 liters, and your intestines secrete another 1.5 liters of stuff for a total of 7 liters. This means that with the 2 liters that you put in here, you end up with 9 liters of stuff in your digestive system in the lumen that's outside your body every 24 hours. Now, you should be very comfortable with the fact that, dude, if you don't replace that, number 1, you're going to get really thirsty. Number 2, you're probably going to lose some serious blood pressure and your brain might just mutiny. So let's replace it. The easiest way, well, we could ingest more, but if you're going to poop out 7 liters of fluid, that's going to kind of be an unpleasant experience. So let's not replace it. Let's actually just reabsorb it. Your small intestine absorbs 7.5 liters of stuff every 24 hours. Your large intestine absorbs the other 1.4 liters, leaving you 0.1 liters of stuff to excrete in doo-doo every day. Now, 0.1 liters, that's 1/10 of a liter. That's not even close to a 2-liter pop bottle, that's what, a 1/20th of that? So you tell me, old boy, is this possible? I mean, I guess if he saved it up for like 100 days or something like that, that might be possible. I'm just going to let you think on that. In the next section, we're going to look at how nutrients, the mechanism by which specific nutrients are broken into smaller pieces for absorption.